My name is Valeria Gardea, and I'm a biomedical engineering student. And in this video, I will explain how LEDs work. It was made for my electronics class. Before I start explaining what a LED is, it is important that you know what a normal diode is. Now, the letters LED stand for light emitting diode. These types of diode have voltages that vary from 1.2 volts to 3.2 volts. They can be made out of gallium arsenide or gallium arsenide phosphide, which this last one can produce a bigger voltage. These electronic components work by electrons and holes that are injected, and they become excess minority carriers. So they combine with the majority carriers and they produce the photons, like in this picture. In this picture, we can see how LEDs are represented while drawing them in a circuit. They look exactly like a diode, but the difference is that they have these little arrows in one of its sides. In our everyday life, we see diodes everywhere. For example, in the streets or in our houses, they usually are better because they save energy. In cars, they also use them, and for example, for Christmas lights, they can use them outside our houses or even in the Christmas tree. Okay, so we're going to analyze now this LED. The maximum current that can pass is 30 milliamperes and its voltage is 3.2. So here we have this current, and we can, to get this resistance that we don't know, we can do a mesh. We will have 10 minus 10, and it will go like this: minus 10 plus 30 times 10 to the minus 3 times R plus 3.2 equals 0. So with this, we know that the resistance value is 226.67 ohms. So that the LED can't have no damage, the resistance that will work here is of this value. In this next case, we have the same scenario, but we have three different LEDs in parallel. If we write here the same resistance, 226.67, these LEDs won't work because the current that passes through here, 30 milliamperes, will divide here, here, and here. So this is the maximum current needed so that the LEDs can work. And if it's divided by 3, each one will have 10 milliamperes, so they won't work. So this case is useless. So now analyzing the same type of LED and trying to correct the one we saw before, I wrote a resistance here, one resistance per LED, so that each current that passes through here, here, and here is the same, 30 milliamperes. So now the question is, what is the current that will go through here? In this case, we will just add 30 plus 30 plus 30. So we'll have here 90 milliamperes passing through this. Why are we doing this? Why are we adding? This is because in each node here, when it passes through here, it will leave just 30. So now here we're gonna have the rest of the current left, and a part of it will go through here, and the rest of the current will go through here. So now that each one has 30 milliamperes, and the resistance is the same as the one we calculated before, 226.67 ohms, these LEDs will work correctly.
For watching my video.